Math isn't just about solving for x in a vacuum. It's the hidden engine behind how Nasir sells fruit, how hotels charge for rooms, and even how ships navigate the ocean. Today at STEMBridge, we're diving into exercise 8.4, where we take the geometry of straight lines and apply it to real life situations. By the end of this video, you'll see that every linear equation is actually a story waiting to be told. Let's decode these real world blueprints together. A masterclass in real world math, decoding the stories in exercise 8.4. From world problems to wisdom, every day we face challenges involving money, time, and resources. Behind each of these challenges is a pattern, a relationship that can be described with a straight line. Today, we learn to see that line. We learn the language of linear equations to turn complex problems into clear solutions. Question number 1. The fruit seller's dilemma. Nasir sold fruiters at 120 rupees per dozen and Shakri Malta at 150 rupees per dozen and earned 1200 rupees. Write an equation in standard form that describes the situation. Firstly, let x be equal to the dozen of fruiters which is at 120 rupees per dozen, and let y be equal to the dozens of Shakri Malta at 150 rupees per dozen, and the total earnings that Nasir earned is 1200 rupees. For the second part, if he sold 4 dozens of Shakri Malta, how many dozens of fruiters he sold? The equation that we developed right now is 120x plus 150y being equal to 1200. Given in the second part, the value of y is 4, we substitute 4 into the equation. That means 120x plus 150 into 4 is equal to 1200. 150 into 4 is 600 and 1200 gets subtracted with 600. That leaves us with 600. If we divide 120 on both sides of the equation, we will get the value of x, or simply the dozen of fruiters. The answer is 5. Nasir sold 5 dozen fruiters. In question 2, the hotel bill breakdown. The linear equation y is equal to 1450x plus 2000 describes the total cost for staying in a hotel for one day, where 2000 rupees is the rent of room for maximum 8 people and 1450 rupees is the food cost per person. So in this equation, the total cost is represented by y and x basically denotes the number of people. For part number 1, we need to find the cost for a group of 7 people. That means we will replace the variable x and write our value which is 7. 1450 into 7 is 10150. Here 1450 gets multiplied with 7, that gives us 10150, and it gets added with 2000. That means that the y, or the cost for 7 people, is 12,150. For the second part, we need to determine how many people can stay for 13,600 rupees. That means the total cost, or y, gets replaced by the value 13,600 and 2000 gets subtracted with that, we get 11,600. It gets divided by 1450 to find the value of x, which is 8. This means that 8 people can stay for 13,600 rupees. In question 3, the career choice. If one company provides 5,500 rupees per week along with an extra bonus of 700 rupees, and the other offers 800 rupees per day, we need to convert this data into linear equations and tell which offer is better for 2 weeks. Looking at the first option, which is of company A, if we decode the data into a linear equation, we get y being equal to 5500w plus 700. Here w stands for the number of weeks. Okay, for 2 weeks we need to find the value of y. So if we replace w with 2, 5500 into 2 gives us 11,000, and 11,000 added with 700 is 11,700. For the second company, if we decode the data into a linear equation, we get y is equal to 800d, where d is the number of days. But we have 2 weeks. So first we will convert the weeks into days. We know that in 1 week we have 7 days. 7 into 2 will be the number of days that we have. So y will be equal to 800 into 14. That leaves us with 11,200. The verdict: Company A is the better offer for 2 weeks as it pays 500 rupees more than Company B. Moving on to question number 4. The earning power explained. A man earns 120 rupees per hour. He has 500 rupees in addition with him. For the first part, we need to write a linear equation and find his amount after 12 hours. Suppose y is the total amount and x is equal to the hours worked. The equation will be y is equal to 120x plus 500. For 12 hours, we will change the value of x to 12. That means 120 into 12 plus 500. That is 1440 plus 500. Our answer is 1940 rupees. This means that he will have 1940 rupees after 12 hours. For the second part, what do the slope and y-intercept represent? The slope here is 120. This is the rate of earning. For every hour the man works, his money will get increased by 120 rupees. The y-intercept, which is C here, it is the starting amount. Before he works any hours, the value of x is equal to 0. He already has 500 rupees. The anatomy of a linear equation. Look at the above equation. It is y being equal to 120x plus 500. What does the slope and the y-intercept tell us? The slope tells us the rate or how fast something is changing. It's the per hour, per day, or per unit value. A bigger slope means a steeper line and a faster change. The y-intercept here, C, is our starting value. It's the amount we have before the change begins. When x is equal to 0, it's the initial fee, the base amount, or the flat rate. Moving on to question number 5, the electricity bill uncovered. Ali shifted in a rented house on 1st September. The electric meter of the house was showing 44 units on that day. If the average electricity consumed is 18 units per day, for part 1, represent the situation through a linear equation. For part 2, how many units are consumed till 30th September? And for part 3, what will be the bill after 1 month at 20 rupees per unit? Decoding the data, the starting unit is y-intercept, which is 44. The rate of consumption, which is our slope, it is 18 units per day, and the cost is 20 rupees per unit. If we develop our equation for part 1, it will be y is equal to 18d plus 44. Y is equal to the total units, while d is equal to the number of days. For part 2, 30th September, that means 30 days. The units consumed will be 18 units a day multiplied by 30. That is exactly 540 units. And for the third part, the bill. The bill is 540 units into 20 rupees per unit, which gives us 10,800 rupees. Okay, moving on to the next part of question number 5, the electricity bill being uncovered. For part 4, after how many days will the meter show 404 units? The equation that we had was y being equal to 18d plus 44. We will change the value of y to 404 to find the number of days. That means 404 gets subtracted from 44 and divided by 18. That means 20 days will be our answer, or the meter will show 404 units after 20 days. Moving on to question number 6, the taxi fare formula. Alia hired a taxi with a fixed charge of 1,500 rupees plus 450 rupees per 30 minutes. It's easier to use a rate per hour. The rate is 450 rupees per 30 minutes, which means 900 rupees per hour. The fixed charge, which is the y-intercept, it is 1,500. So our equation will be established as y being equal to 900h plus 1,500. Here y is the total fare and h is the number of hours. For part 2, we need to find what will be the cost for 5 hours. So we will change the value of h to 5. 900 into 5 is 4500. It gets added with 1500. That means the cost for 5 hours is 6000 rupees. For part number 3, we need to find the slope. The slope of the equation is 900. It represents the cost per hour of travel. Moving on to question number 7, decoding the temperature scales. We need to derive the relation between Fahrenheit and Celsius scales in slope intercept form. And then what does y-intercept and slope show in the equation? What is the temperature in Fahrenheit when temperature in Celsius is 500 degrees? For part number 1, the established formula in slope intercept form is Fahrenheit is equal to 9 by 5 Celsius plus 32 degree. For the part 2, we need to find the slope. The slope is 9 by 5, or in a decimal point of view, it is 1.8. This means for every 1 degree increase in Celsius, the Fahrenheit temperature will increase by 1.8 degrees. The y-intercept here is 32, and that means when the Celsius temperature is 0 degree, which is the freezing point of water, the Fahrenheit temperature will be 32. If we want to convert 5 degree of Celsius to Fahrenheit, we can simply place the value. Fahrenheit is equal to 9 by 5 into 5 plus 32. That is 9 plus 32. That means the temperature will be 41 degree Fahrenheit. You now speak the language of lines. Today, we didn't just solve math problems. We modeled fruit sales, compared job offers, calculated bills, and translated scientific scales. You've seen how a simple line can bring clarity to complex situations. This is your new toolkit. You can use it to see the patterns around you and make smarter decisions. The Code Breaker's Guide to the Real World, a masterclass in applying real linear equations. The four-step method for decoding any problem. The first is to deconstruct. You need to identify the essential data and the core question. The second is to model. You will choose the right mathematical tool and build your equation. The third method is to solve, executing your steps with algebraic steps and precision. The fourth method is interpret, translating the numerical answer back into a meaningful and real world conclusion. Case study number 1, we need to predict a cricket team's performance. A cricket team scores 96 runs in 16 overs and 180 runs in 30 overs. We will model their scoring rate to make future predictions. Firstly, we will deconstruct and model. We will find our data points. The scores are 96 runs in 16 overs. That means our first coordinate will be 16, 96. And for the second, we have 180 runs in 30 overs. That means our second coordinate will be 30, 180. Now we will choose the model. How do we find the equation of a line with two given points? First, we will calculate the gradient. Then we can use the point slope form, which is y minus y1 is equal to m bracket x minus x1. Solving for part A, we will calculate the run rate or the gradient. Gradient is equal to y2 minus y1 divided by x2 minus x1. Substituting the values, 180 subtracted from 96 is 84 and 30 subtracted from 16 is 14. 84 divided by 14 is equal to 6. That means our gradient is 6. Solving for part B, we will build our equation. We know that y minus y1 is equal to m bracket x minus x1. So substituting the values that we found for the first coordinate, y minus 96 is equal to 6 into x minus 16. That means y minus 96 will be 6x minus 96. Y will be equal to 6x. This is our final equation. Interpret and predict the story that these numbers tell us. Our equation is 6x. What does the gradient mean here? The gradient, which is 6, it is the run rate. The team scores an average of 6 runs per over. The y-intercept here is simply 0. That means at 0 overs, the score will be 0 runs. Okay, for part 4, we need to find the prediction for 45 overs. Simply replacing the value of x to 45, we get 270 runs. And what will be the overs to score 240 runs? Simply change the value of y to 240 and you will find the value of x, which is 40 overs. Case study number 2, business logistics. We will analyze a truck rental's pricing structure. A truck company charged $5,000 per day and some additional money per kilometer. He drives 120 kilometers and paid 30,000 rupees. We need to determine the company's full pricing model. Firstly, we will isolate our variables. The total cost, which is C, for 125 kilometers is 30,000 rupees. The fixed cost, which is the y-intercept or C, is 5,000 rupees. The variable cost for 125 kilometer is 30,000 subtracted from 5,000, which is 25,000. Now step 2, we will model the per kilometer rate, basically finding the slope. The slope will be the variable cost divided by the distance. So our variable cost was 25,000 divided by the distance, which is 125. So we get our slope, which is 200 rupees per kilometer. Now we will use the slope intercept form, which is y being equal to mx plus c, to write our equation. So we get c is equal to 200 into d plus 5,000. Now we will solve and interpret. For the part 1, we will use the point 125, 30,000 and the slope as 200. Placing the values, we will get our answer. C minus 3000 is equal to 200 into D minus 125. Per kilometer charge. The charge per kilometer is basically the slope of the line, which is 200 per kilometer. What will be the cost for 180 kilometers? Simply replace the value of D. We can just write y is equal to mx plus c, where c will be equal to 200 into x, which is 180, plus 5,000. If we add the values together, we get our cost for 180 kilometers, which is 41,000 rupees. Moving on to question number 3, global navigation. We will charter a ship's course with coordinates. A ship started traveling from Karachi with a latitude of 25° north and longitude 67° east. If the ship travels in a straight line and reaches a destination with a latitude of 32 degrees north and longitude 54° east, we will need to derive the equation of a line in point slope form. If the ship moves to another location with a latitude of 39 degree, what will be the longitude of this location? Firstly, we will deconstruct, model, solve and interpret. Deconstructing the problem, let x be the longitude and y be the latitude. That means our point 1, which is of Karachi, it will be 67,25. And our point 2, which will be our destination, it will be 54,32. If we find the slope, which will be y2 minus y1 divided by x2 minus x1, we get our slope in a negative value, which is negative 7 by 13. Now we can use the values that we have, like the points and the slope, to find our equation of line. The point slope form is y minus y1 is equal to m into x minus x1. So we get our equation, which is y minus 25 is equal to negative 7 by 13 into x minus 67. Okay, now we need to find the longitude, which is x, when our latitude y is 39 degree. Placing the value of y to find the value of x, we get our longitude as 41 degree east. Case study number 4, architectural design. We will model proportions in a building plot. The length and the width of a plot are in the ratio 2:1. Write the equation of a line and find the length of plot if the width of a plot is 30 feet. Modeling and interpret. The rule of proportion. The relationship is length divided by width, which is 2 divided by 1. Let L be the length and W be the width, which means L is equal to 2W. If we solve, that means if we find the value of L, if our W is 30, 30 into 2 is 60. That means our length is 60. Now what does the slope here mean? In the equation, which is L is equal to 2W, like Y is equal to 2X, the slope is 2. This means that for every 1 foot increase in the plot's width, the length must increase by 2 feet to maintain the 2:1 ratio. From problem to playbooks, your universal toolkit. Mathematics is not just about numbers, it's about having a powerful framework to understand and shape the world around you. The same four-step method allowed us to analyze sports, calculate business costs, navigate the globe, and design a blueprint.